Okay, the first thing I want to do this morning is to go through the solutions of the exam paper questions on surds and number systems and make sure that everybody understands what they were asked for. So the first question didn't look maybe like a surds question, except give your answers in the form a plus or minus the square root of b. So you're going to use your minus b formula and you're going to leave the square root sign in your answer. Where a, b elements of n, where a and b are whole positive numbers, natural numbers. Okay, so if I want to solve this equation here, I'm going to need to use my minus b formula. And the minus b formula is that x is minus b plus or minus the square root of b squared minus 4ac, excuse me, all over 2a. And that all over is important. The minus b is on the top of that fraction as well. A, B, C. Because my quadratic is lined up with x squared x and a constant, I know the values of A, the x squared coefficient, B, the x coefficient, and C, the constant. Filling into the formula, I get x equals 2 plus or minus the square root of b squared minus 4ac. When I did minus b, minus a minus 2 is a plus 2. So I just dropped that minus straight away there. It just makes things a little bit neater as I work. All over 2a. Now my recommendation, which I said to you in class, is that we take this part, including the square root, and type it into our calculator in one go. If there's a surd in the answer, the calculator will give us a surd as well. You don't type the whole thing in, just the square root part on its own. So what does that look like? Square root sign, bracket, minus 2, close your square root, squared. Minus 4, bracket 1, bracket negative 4. So make sure that it matches exactly what you've written down. And we get 2 times the square root of 5. So the calculator's done all the hard work for us. We've 2 times the square root of 5 here. The next step then is to simplify that. So this can be written as x equals 2 plus or minus 2 times the square root of 5 all over 2. And we wouldn't leave our answer like that because the question said that my numbers, it said nothing about a fraction. I must have whole numbers. So just type the plus part into the calculator and see what happens. Fraction button, 2 plus the square root of 5, 2 plus 2 times the square root of 5 over 2. 2 divides into everything and we get 1 plus the square root of 5. A and B are both 1. 1 plus the square root of 5. They didn't ask us to find the values of A and B. Some people get confused when it says things like in the form. In the form just tells me what's the pattern of my answer going to look like. So the pattern of my answer should be a number, I forgot my minus, a number plus or minus, so I'm just copying down the plus or minus there, the square root. If they'd asked for decimal places, we'd fill in the plus value and press the change button on our calculator, and fill in the minus value and press the change button on our calculator. But we didn't need to do that because this is the format that they wanted the answer in. So that's the final answer. Okay, the next question here. They've reminded us of one of our laws of surds. So this given that here, that's just one of our laws of surds. They won't always tell you that, but they're kind of being kind, reminding you. What happens when I multiply out and simplify these brackets here? So I've got c plus the square root of d all squared, which means c plus the square root of d multiplied by c plus the square root of d. And we just multiply these out the same way we would any other brackets. C by c gives me c squared. C by the square root of d gives me c times the square root of d. I don't know the values of c and d. We're just sticking the letters together like that. Plus d times c, still put the c in front, c times the square root of d, and plus root d by root d. Well, we were told that that is just d. These are like terms because I have the same radical. I have the same number underneath the square root sign, and this then becomes c squared plus d plus 2c times the square root of d. If you wrote it in a different order, that's fine as well. We can't simplify that any further. So that's the full answer. Now, let's move on to part C. The table below shows whether each of the given numbers is a natural number, an integer, a rational number, or an irrational number, which doesn't have its own symbol. So we completed, we had a similar question to this for homework. 16 is whole and positive, which means it's also a whole number, which means you can also write it as a fraction, which means it's not an irrational number. So these guys are mutually exclusive. If one of these is yes, the other must be no. The square root of 6 is not a whole number of any kind, and also we can't write it as a fraction because it is an irrational number, it's a third. 2/3 is not a whole number of any kind. It can be written as a fraction, it is written as a fraction, therefore it isn't irrational. -4 is not a positive number, it's not a counting number, but it is a whole number, and it can be written as a fraction, which means it's not an irrational number. So that's how we have to fill out that table. If you had difficulty doing that, and you still don't understand why things are categorized like that, just let me know in a question and I can go through it again. Right, the next question. Place these numbers in order, starting with the smallest. They didn't say to do it without using our calculator, so the first thing I do is I type them all into my calculator and change them to decimals. This is 1.5, this is already a decimal, 1.4. And what about the square root of 2? Now we know that it's an infinite decimal. Square root of 2 is 1.41. Let's just go to 3 decimal places. 1.412 and so on. So the smallest number here is this one. In order 1.4. The next smallest is the square root of 2, and the biggest one is 3/2. You need to write them in their original form for the answer, but you can use your calculator to help you. Which of the following numbers here is not a rational number? So it's not a rational number if you can't write it as a fraction. If you can't write it as a fraction, and how can we tell if we can't write it as a fraction? The decimal expansion of it doesn't terminate, doesn't stop, and it doesn't repeat. There's no repeating pattern. This one here can be written as a fraction. This one here can be written as a fraction, 3,142/1000. This could be written as 22/7. This is 22/7, so it's already written as a fraction. And this one cannot be written as a fraction. So my explanation, pi is not rational. You can't write it as a fraction of integers. I can't write it as one whole number over another. This explanation or this explanation will get you full marks, whichever way you feel like writing it. Next part, all they were asking us to do was subbing in. So they gave me a formula. What happens when n is 17? 4/17 squared plus 1/13. What happens when n is 19? 4/19 squared plus 1/13. And when n is 21, 4/21 squared plus 1/13. You wouldn't leave your answer like that. You have to evaluate them using your calculator. Well, you can do it without the calculator if you prefer. But if you want to make sure you're accurate, using the calculator is probably the safest way of doing it. So I get 89. And the great thing about typing it into my calculator is I can come back using the arrows and delete that 17 and change it to 19 and save myself some time. So here I get 1445 over 13 and 21. We get 1765 over 13. Which one of my answers is a natural number? Only one of them. So 89 is a natural number when n is equal to 17 because it is a whole positive number, which is the definition of a natural number. Sorry, my bad writing there. Okay, so I've seen people get really confused with questions like this, even though it's a really straightforward question, just because of the notation that they've been using here. So they've asked us to find the different values of this formula for different values of n. Now, the next question, very similar to the last part of question 1. We're again shown a bunch of different numbers and we have to say what sets they belong to. So the square root of 5 is not a whole number of any kind. It can't be written as a fraction, so it is an irrational number, and it's also a real number, so it's going one step further. The real numbers are all of our numbers. 8 is a whole positive number, which means it can be written as a fraction, which means it's not irrational. -4. It's not a counting number, but it is still a whole number, which means it can be written as a fraction, which means it isn't irrational. 3.5, or 7 over 2 would be another way of writing it. It's definitely not a whole number of any kind, but it can be written as a fraction, which means it's not irrational, and it is, of course, a real number. 3 pi over 4. Not a whole number. Is it a fraction? It looks like a fraction, but my top number, remember, to be a rational number, you must be a fraction of integers. You must have a whole number on the top and on the bottom. So here, we don't have a whole number on the top. So it is not a rational number. It is irrational, and it is real. Okay? In the case of the square root of 5, explain your choice. So I was explaining it there as I filled it in. So we can say the square root of 5 is not a whole number, so therefore it's not in the natural numbers and it's not in the integers, and the square root of 5 cannot be written as a fraction of integers. You can just learn off that way of explaining why something is irrational if you want. So therefore, the square root of 5 is not in my rational numbers. Therefore, it is irrational. So the square root of 5 is in the real numbers, but not the rational numbers. It's in the set of irrational numbers. That's maybe a bit more than you'd have to write down. You probably didn't have to say anything about it being a whole number, but you would have to talk about this. It can't be written as a fraction of integers, or its decimal expansion doesn't repeat and doesn't terminate. Now, the last part of the question. Use the properties of surds. So we can't just write down the answer that the calculator is going to give us. In fact, they told us the answer that the calculator is going to give us. So if we did the square root of 98 minus the square root of 18 plus the square root of 2, we see that we do indeed get 5 times the square root of 2, but that doesn't help us. Now, if you're really, really stuck, and you won't get full marks for this, you could do each part in turn. 7 root 2 minus 3 root 2 plus root 2. What they really want to see, though, is can you identify the perfect squares? So we're going to look for perfect squares that divide in to each number. We've done similar questions to this with your homework. So 98 is divisible by 49, which is the square of 7. So we can rewrite this as, instead of the square root of 98, the square root of 49 multiplied by the square root of 2, because 2 times 49 is 98. What's the perfect square that goes into 18? 9. So the square root of 9 by the square root of 2 plus, this is just the square root of 2. And then we change the perfect ones, the perfect squares, into numbers. Square root of 49 is 7, root 2 minus, square root of 9 is 3, root 2 plus the square root of 2. And then those are like terms because I have the same number under the square root sign, which means I can add the number in front. 7 take 3 is 4, 4 plus 1 is 5. So that's 5 times the square root of 2, which is exactly what they asked us to show. Okay, thank you very much.